All right, guys, so I went ahead and pulled up the notes and stuff. I'm actually going to teach the lesson live today because, well, we figured out in first period that something happened when I tried to make the video where it didn't really work out, like my screen stopped presenting. So the video is not helpful, so instead of a video, you guys are going to be my video. Like I'm hoping to be able to record this and it helps. So if you have a TI-30, or sorry, a TI-83 or 84, kind of get that out. We're going to practice using that today. If not, you're going to want to go to www.desmos.com. Okay, a lot of you guys are probably familiar with that, but if not, type that in, and then I'm going to show you. You know, the good thing about using Desmos is it's pretty easy and pretty user friendly. Like you can figure a lot of stuff out on your own. The bad news for using Desmos in this class is that I'm not going to really do a lot of direct teaching to it. So if you are using Desmos, you're going to have to learn some stuff on your own. So just right at the beginning, I want to tell you guys who don't have a graphing calculator, you're going to want to go to the material for 2.5. So follow the link. And pull up here in a second. And then so normally we have two attachments, the blank notes and the filled out notes. But today we have a third. So this bottom one that says 2.5 and then linear regression, ... You're going to kind of open that. And I don't know if you might want to print this out eventually. But this part up front will basically summarize what we do in class for graphing calculator people. But there is a page 2 that'll show you how to do what we're doing on Desmos. So if I didn't have a graphing calculator, what I would try to do today is kind of follow that page 2, okay? That can be found in the material for 2.5. I would try to follow along with at least one of the examples I do in class, okay? Because I'm not going to show you how to do Desmos because I just don't have time, okay? I'm going to teach to the graphing calculator, all right? So hopefully that makes sense. And here we go. So basically, our learning target today for lesson 2.5 is we want to be able to make a model using our technology for a set of real world data. So basically a scatter plot, we want to be able to model that with a linear model, okay? So like a line of best fit, you'll hear that called. And then the other part is we want to be able to use our model to make a prediction, okay? So I'm going to kind of skip ahead in our notes because the first two examples are all about making scatter plots and drawing a line of best fit by hand, but you don't need to do that. So I'm going to skip. Well, I'll kind of breeze through it. How about that? So the first thing says real world data doesn't usually fit on a perfectly straight line. However, we can model real-world data using a linear equation. That really should say some real-world data because some real-world data doesn't really even follow a line either, okay? Sometimes it's other regression, but for right now, we're going to use linear. All right, so some examples of what I mean, just big picture-wise, are right here, right? So we all know what a scatter plot looks like. But looking at this one, you can see there's definitely a trend as we move to the right on the graph. The data seems to increase, right? So we would call this a strong negative correlation. Not linear, but there's definitely a correlation, okay? And then it gives you some more examples. Weak negative, that's random, so no correlation. Weak positive, and then a strong positive, okay? So again, I'm really going to skip through to the last part because the last part is what you need to know for the homework and for the test. All right, so here is where I wanted to get. Now, if you're using the notes, it says don't have a graphing calculator. I would just mark all this out. So they have a graphing calculator tool on the online textbook. We're going to use Desmos instead of that for those non-calculator people. So mark that out and maybe put Desmos there if you were filling out these notes. Okay, so here's where we're going to get to using our calculator. That says TI-83. Most of you who bought one would have a TI-84. Okay, so same kind of deal. All right, a graphing calculator or scatter plot tool can calculate a line of best fit through your data. This function is called linear regression and will tell you the slope, the y-intercept, and the correlation coefficient. So about R, it says the closer R is to -1 or 1, that basically tells you how strong your correlation is. We'll get more into that tomorrow, but I do want you to start by doing this. So if you have a graphing calculator, the first thing you want to do before we start is you want to go to catalog, okay? So you want to hit second and 0. Second, 0, go to catalog. Now, I'm not going to do this because it'll take too long, but you're going to arrow all the way down to where it says diagnostic on. It's a lot of arrow down, okay? This is in alphabetical order, so I'm just going to show you how long it might take. I'm not going to go all the way there, but you can see I'm just hitting arrow down, and it just is going to take a while to get to diagnostic on, okay? Once you get there, you just want to hit enter by diagnostic on. If you don't, you can find the slope and the y-intercept, but it won't tell you R. So if you get a question about R, then you won't be able to have that, okay? The good news is you only have to do this once. So like mine's already on, that's why I'm not going to do it again, okay? So try to turn that on, and if you can't find it, I'll help you with it tomorrow. We are going to spend more time on this tomorrow. But let's get into actually making the line of best fit. So our actual example says this. Use your graphing utility to find the equation of the line of best fit for the data. Then use your equation to predict the cost in 2025. So this is what a test question over this might look like, okay? And it's got all of our learning target in there, all right? So if you ever have time in there, it's going to be in years, all right? And we want to basically do it this way. This is what it's going to say on the test. It'll say, make 1995 be x equals 0. Okay, so we're going to write that out. I say we. I know you guys don't have these in front of you, but we're going to set 1995 as year 0. Okay, so my input variables are my years, and my output variables are my average cost per movie ticket. Okay. And I know you guys can't see it. If you pull it up on your computer, you might be able to see the numbers a little bit better. All right, so at that point, now that I've kind of got what I want to do, this is what we do next, okay? So pretty much everything we want to do for this is in stat, or a lot of it anyways, okay? So I'm going to go to stat, and then I want to edit a list. That's how you input data from a table, okay? So I'm just going to hit enter. All right, now my list is already full. If yours is blank, don't worry about this next step. But if it's full, here's how you can quickly clear it out. Okay, and all this is on that list I gave you. All right, so you can hit, go back to stat and go to clear list. This is a good shortcut. And then you want to clear out the L1 and the L2 columns, okay? So how you pull that up is you hit second and then stat. See, list is above stat. And we want to clear out L1 and also L2. So you need to separate those with a comma. So your comma is right there above the 7th. And then L2, so second, and then list again. I hit enter, and those will be cleared out. So again, I want to go into stat, and I want to edit my list, okay? So remember, my first list, 1995, we called year 0. So 97 would be year 2, and so on. 4, 6, 8, 10, 12. All right, so you just type that in, 0, enter. 2, enter, and so on. I always like to just give it a quick look over because it's easy to miskey something, okay? Now that I have my X's in there, I want to get my outputs in there, okay? And again, I know it's kind of hard to see. Just to make sure I do it all right, I'm going to look at my paper because it's hard to see on the screen. So first one is 435. You always have to hit enter after, and then 4.59, enter. 5.06, enter. If you guys see me make a mistake, just speak up. 565 and then 603, enter. 641, enter. 688, enter. Again, I always double check here because if you mess something up, obviously your line of best fit is not going to come out right, okay? Now we have our data in, right? Our inputs always go in the L1, our outputs always go in the L2, okay? Once you have that, you go back to stat, and then you want to find linear regression, AX plus B. Notice that is not on my screen, okay? It's not in the edit part. It's in the calc part. So you arrow over to calc, and then it is option 4, linreg, AX plus B. I like to just type 4. You can arrow down if you want, okay? At this point, you want to just hit enter. You have to hit it about 4 or 5 times until it spits out the numbers. All right, so if you get there, then you're in good shape, right? So look at my numbers and then look at your numbers, okay? So what this means is A is the slope of my line of best fit. B is the y-intercept of my line of best fit. So based on what I'm seeing in the calculator, and obviously I don't want to write that whole decimal, I'll round to the nearest hundredth. So I'm going to say f of x, use function notation, is approximately equal to, that's going to round to 0.22, so 0.22 times x, plus 4.26. So again, just think about what we've said here. Our output variable, which represents the cost of a ticket, is equal to 0.22 times the number of years past 1995 plus 426. That's basically what we've said, okay? So this is our model. Obviously, that's the hard part. Once you have your model, it's pretty easy to make a prediction, okay? So our prediction is going to be for the cost in 2025. All right, so in 2025, think about if 1995 is year 0, then 2025 would be year 30, right? Because that's 30 years after. If you plug in 2025, that's going to give you an answer that makes no sense at all, right? So if we find f of 30 then, that would just be 0.22 times 30 plus 4.26. And that is, you type that in, 1086. Okay, so just to put it in context, that's $10.86. Obviously, this is not accurate data because movie tickets now cost more than that. But that's basically kind of what we're doing. All right. So the list, if you're following the list, you might see that I did about half the list. Okay, that's all you really have to know. All right, and we'll get more in depth with it tomorrow. But see if we have time. I think we do. I'll show one more example with what I just did. Okay, if you don't, maybe. If you weren't able to keep up that time, maybe try again on the next one, okay? Any questions, though, before I go on? Any really specific questions besides I wasn't able to keep up? All right, so let's look at just one more. There's one more example here. All right, so basically, I'm going to skip the words there. It basically says, if I give you the population in millions, and then we're going to compare that to the number of drivers in millions, right? So number of drivers is a function of the population, right? So this would be my x variable, this would be my output variable. And notice time isn't involved, so I don't need to do like anything like 2.7 equals 0 or anything. I'm just going to enter them as I see them. Okay, so we'll just go ahead and get right to it then. All right. So I know that I need to clear out my list because I already have a list. So I'm going to do the clear list thing again. And I want to clear out L1 and L2. So L1, comma, and then I hit second list, pull that up, and then L2 is option 2. Those are cleared out. Now I'm ready to enter. Okay, so I go back to stat and then edit. My inputs need to go down L1, right? So Arkansas is 2.7. Illinois is 12.4, and that's just overall population. 2.7. 6.4, and so on. So I'll leave that up for a second. I know you guys can't really see those numbers on my screen, so if you're trying to keep up, you probably can't see them at all. I don't know. Maybe you can. And then we're going to do number of drivers as our output, right? So Arkansas has 1.9 million drivers, so 1.9, then 7.7, 1.8, 4.4, 8.3, and 12.8. Okay. Again, at this point, it's always good to do a little check. Did I get this right? Do I have it all right? Okay. Once I know that I do, I go back to stat. I go over to calc, and now I want to calculate it, right? I want to calculate it as a linear regression. Okay, so that's option 4. Enter, 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 enter. And there we go. Okay. So based on what I see in the table there, our model for this data is going to be f of x is approximately equal to 0.61 times x plus about 0.36. All right, so that's our model that we're going to use. And then the last part is, no, I kind of skipped this, but it says, if Michigan has 10 million people, how many drivers does it have? So in other words, if x equals 10, what does f of x equal? So we're just going to find f of 10. Let's see what time it is. I'm going to see if I can show you guys another way. I might just wait till tomorrow on that. All right, so I'll show you an alternate way. So the easy way, I think the easy way at this point is just to plug 10 in. 0.61 times 10 plus 0.36. That'd be easy enough, okay? But this will kind of lead into tomorrow. Here's another way to kind of find that, all right? So another way you can do that is to go to y equals and type in your function rule, okay? So 0.61 times x plus 0.36. All right, once you have that, you can look at the graph, but we don't really need to. We're going to look at a table of values, okay? So I'm going to hit second graph. And mine is messed up, so let me fix it real quick. We'll go through how to do all this tomorrow. But this is going to be on auto for you guys, so you won't have to do this step. All right, so there's my table of values. 1 goes to 0.97. 6 goes to 4.02. Remember, we're trying to find f of 10. All right, so I can just look at my table and see that 10 goes to 6.46. So by looking at my table, I can just know that the answer is 6.46. So again, what's that mean? That means 6.46 million drivers based on the population of 10 million people. Okay, so I recorded this. I'll send this out as a video so you can pause it, rewind it, and whatnot. I will post your homework. You can get started on it if we have time, but we will have time in class tomorrow. We're not going to do a new lesson. We're going to spend more time on this because this is one that people struggle with, okay? So just know that going in. And if you don't struggle, you know, find somebody to help out with it. All right, so let me go ahead and end the recording here, and then I'll take questions. Give me 1 second, sorry.